Today topic is error analysis. Note point is no measurement is accurate because all measuring instruments can measure up to certain value or up to some minimum value. From below that minimum value it cannot measure accurate. That minimum value called least count. We have different measuring instrument having different least counts. For example, millimeter scale has a least count of 1 millimeter, centimeter scale having least count of 1 centimeter. Beyond below that value, it cannot identify the accurate value. That's called least count. Is a major cause of errors in devices. Primary source of error is least count. Types of errors are two types. Those are systematic errors and random errors. Random errors, the cause of error is unknown. How to eliminate the error? We don't have particular procedure to eliminate random errors, so we have to do repeated measurements and average it. The resultant can be taken as a true value. Second type of errors is systematic errors. The cause are known to us. That means why the error is occurring, we know. So we have to minimize that by adjusting the cause. The causes may be temperature, pressure. We can adjust temperature by changing the place, pressure. We can changing the cause and minimize this error. Mathematical analysis on error. This is a main topic for math mathematical problems point of view. Absolute error means true error. The difference between true value and measured value of a quantity is called absolute value. The average value AM of repeated measurements are taken as a true value. A mean or true value is equal to first measurement plus second measurement plus nth reading measurement value by n gives a mean value or true value. Absolute error in measuring values of quantity are delta A1 equal to measured value minus first measurement value. That means delta A1 first absolute error equal to true value or mean value minus first measurement value. Second time measured second time absolute error equal to mean value or true value minus second reading and so on. Nth absolute error equal to true value minus nth reading. Mean absolute error for different measurements it gives a different absolute error. So we have to average it gives a more accurate absolute error that called mean absolute error. This value can be taken in the problems. Arithmetic mean of the magnitudes of absolute error in all the measurements is called mean absolute error. That's the formula is delta mean equal to first absolute error plus second absolute error plus third time absolute error and so on nth time absolute error by n. Relative error or fractional error. The ratio of mean absolute error to the mean value or true value of the quantity measured is called relative error or fractional error. The formula is relative error equal to delta mean means absolute error by true value. The percentage errors will help in mathematical operations like product or difference. We have to simply add the errors. For example, two quantities are to be multiplied. Then we have to find error in that multiplication. We just simply add two percentage errors or fractional errors of that individual quantities. Errors in sum or difference. The maximum absolute error in sum or difference is equal to sum of absolute errors of that particular individual quantities. For example, two quantities are to be addition. What will go into the error is just to add those absolute errors that will give the resultant error in sum or difference. Errors in product or division. The maximum value of fractional errors is errors in product or difference of two individual quantities is also the sum of fractional errors in individual quantities or sum of percentage errors in individual quantities. For sum or difference, we have to add absolute errors. For product or division, here also we get fractional error is sum of fractional errors of individual quantities. Why we have to add means we have to get a maximum value of error. So we have to get maximum value of error in case of only addition. That is the formula of fractional errors in productors difference. For addition of percentage errors, the percentage errors in x equal to percentage error in A plus percentage error of B. Take a look at powers. What we have to do when two quantities are to be measured when they having powers, we have to just logarithm it and differentiate it. We can get the answer as percentage error as relative error in resultant equal to power of relative error. Here also we have to take a plus because we have to get maximum possible error. So plus power of second quantity of relative error. Take a look at that problem. The volume of the liquid is 5 plus 2% cubic centimeters. Density of liquid is 0.9 plus 1% of gram per cubic centimeter. What is the mass of the liquid? Mass of the liquid, we know the formula. Mass of the liquid equal to volume into density. Volume of the liquid is equal to 5 plus 2% cubic centimeters. Density of the liquid equal to 0.9 plus 0.1% gram per cubic centimeter. Volume mass of the liquid equal to volume into density. Absolute mass means absolute volume into absolute density, that equal to 5 plus 9. 5 into 0.9, that equal to 0.45 grams. And now we have to find the percentage error in mass. We know the percentage errors in individual quantities, those are volume and density, but we have to find percentage error in resultant, that means mass. We know percentage error in product is sum product is a sum of percentage errors of individual quantities, that equal to 0.2 percentage plus 0.1 percentage, that equal to 0.3 percentage. The resultant mass of those liquid is 0.45 percentage plus 0.3 percentage. The second problem is the resistance R1 equal to 1 plus 0.5. Here we get absolute error 1 plus 0.5 ohm, and resistance to R2 is 2 plus 0.6 ohm are connected in series. What is net resistance? We know in series the resultant resistance is R1 plus R2. Here we get R1. Here he is given as R1 equal to 1 plus 0.5 ohm, R2 equal to 2 plus 0.6 ohm. The net resistance in series equal to R1 plus R2. We know that sum of quantities in sum of quantities, the error is a sum of absolute errors of individual quantities, that equal to 0.5 plus 0.6. That is the resultant error of resultant resistance. And net resistance is R1 equal to 1 and R2 equal to 2. 1 plus 2 equal to 3, and plus resultant error is 1.1 ohm.